Hello Year 10. Welcome to your first virtual lesson. We're going to start by doing a virtual revision lesson based on some of the feedback that I got from you. Quite a few of you wanted to go over some of the key concepts that were in the physical revision materials. So we're going to start off, we're going to briefly cover natural causes of climate change. So there's quite a lot of information that I'm going to talk about in this presentation. If at any point you need to, because it's on a video, you can pause it, read the information on the screen, or you can go back and review anything that I've said. So let's get stuck in then. Natural causes of climate change. So we need to start off when we're looking at this with the definition of what climate change actually is. And there's lots of different words which are thrown about that are often linked in with climate change, things like global warming, things like the greenhouse effect, but we need to understand what climate change actually means. So it just refers to any changes in the world's atmosphere. So when we talk about changes, these could be things increasing, they could be things decreasing. So we talk often about the global temperature increasing, but we might be talking about changes in weather patterns as well, or changes in rainfall. In some areas that might increase, in some areas that might decrease. So at any point when our climate changes anywhere in the world, we can define that as climate change. And climate change isn't something that's just for the modern age, it's something that's been going on for a long time. This graph shows, broadly speaking, the changes in our climate over the last 10,000 years. And hopefully you can see that there's not been any sort of period in history where it's stayed the same for that long. If we go back 10,000 years ago to around 8000 BC, there was a really large increase in our temperature, in our global climate temperature. So this was out of the last ice age as our planet began to warm up again. After that, there was this fluctuation. So it went up a bit, it went down a bit, but it didn't change a great deal. As we move forward through history, we get to the point where human beings start actually writing down their experiences of the climate. And so we have these two quite key events in our history that we talk about. So we talk about something called the medieval warm period, which weirdly enough was in the Middle Ages and the medieval times. And it was documented that over many years, the summers were getting better, they were getting longer, the climate was warming up, and things were feeling a lot warmer. So we call it the medieval warm period. After that, we had almost the opposite. So something that's called the Little Ice Age. So again, in historical documents, people talk about the fact that winters get longer, they get colder, it gets harder to grow crops, and people get a lot more problems as a result. So there are these fluctuations over time. It's not something that happens just in the modern era. But if we do look closer to the modern times, you'll start to see that there's this sharp rise in the last kind of 200 years or so, with our temperature beginning to go upwards again. So that's something we're going to try and have a look at and try and understand about why that might be. Before we move on, I've just made a note at the bottom of this slide here about the fact that it's a quite common question in an exam to have a look at a graph like this and be asked to describe it. So make sure you're confident using some of those key words that are down there. So things like fluctuating, going up and down, increasing rapidly, increasing slowly. If we've got a good idea, it will set us up nicely for any questions we get about graphs. So we've established that our climate is changing, but we need to understand why that is. Is that a natural process, something that's happened all the way through history and will continue to do so, or have human beings got something to do with it as well? The truth of the matter is, it's a bit of both. So today we're going to focus on the natural side of things, and then in my next video we'll cover the human changes or the human impact that we have on climate change. There's no way we can talk about climate on Earth without talking about this thing here, the sun. It is the most powerful object that we have close to us, and it is the source of all of our energy on our Earth. So understanding the sun and the role it plays in climate change is really, really important to us. The first thing to say about the sun is it is incredibly powerful. If you think about it, despite being millions of kilometers away, it's still powerful enough to warm us up. It's powerful enough to blind us if we look at it. It's so powerful it can burn your skin even from that distance. So we're clearly dealing with something that is incredibly powerful, giving out an awful lot of energy. But the sun's energy isn't constant. Like with many other things in our solar system, it works on a bit of a cycle. And that solar output, or the energy that the sun gives out, fluctuates and it changes. Sometimes it's giving out more energy, in which case our Earth will begin to warm up. and in other times it's giving out less energy, in which case the energy and that warmth getting to Earth will actually decrease. So even though this has got nothing to do with human beings, this can have a big impact on our climate. So solar output is something to definitely consider when we're looking at why our climate has changed over time. Sticking with space for a moment, we hopefully know that our planet is going around the sun, and we might have seen pictures like this of this kind of nice circular orbit going around the sun. That unfortunately is not actually the case. This simple circle going around the sun is a lot more complicated, and there's a lot more going on than meets the eye. Instead of a regular circular orbit, our planet actually has quite a varied orbit around our sun. Sometimes these changes take thousands and thousands of years, but there are times in our history where we've actually been further away from the sun, and times in our history when we've been closer to the sun. There's also been times in our history when the tilt of the Earth has tilted us closer towards the sun or tilted us further away from the sun. Now this is really important when we talk about climate, because as with any heat source, the closer you are to it, the warmer you are, and the further away from it you are, the colder you are. So at those points in the Earth's history when we've been closer to the sun, we've actually had a warmer climate, and in those periods of time when we've been further away from the sun, we've had a colder climate. Makes sense. These changes in the Earth's orbit are called Milankovich Cycles, and they're named after the scientist who discovered them, called Milankovich. They're sometimes known as orbital geometry as well, so the shape of the Earth's orbit. The important thing for us to understand is that distance from the sun, and actually being closer means you're warmer and being further away means you're colder. If you do want to know a little bit more about this, I'm not going to go into too much detail now, but definitely look at some YouTube videos about Milankovich cycles, and they go into some really interesting detail about these changes. Coming back down to Earth, one of the most important natural processes for climate change is volcanic activity. When volcanoes erupt, they release an awful lot of material into our atmosphere. And as far as the climate's concerned, the things that are really important for us to know about are the gases that are produced in a volcanic eruption, particularly carbon dioxide and sulfur dioxide. These two gases are known as greenhouse gases because when they are erupted, they create a layer around our planet in our atmosphere that acts just like a greenhouse because it traps the sun's energy within the atmosphere, and as a result, our planet begins to build up heat, begins to retain that heat and warm up. So the more volcanic eruptions there are, the thicker that layer of greenhouse gas is, the warmer our planet can be. It's probably easier if I show this in a bit of a diagram. So the next slide is going to go through how this works. So this is a scenario we're in. This is our planet pre-human beings. So we've only got natural materials on the surface of our planet. We've got some volcanoes, we've got some forests, we've got some swamps, we'll have some oceans. Importantly, we have no human beings at this stage. So all of these processes are purely natural processes. Now we've already talked about the sun and the fact that the sun is the source of energy. So at this point, the sun's energy is coming in, it's hitting the Earth. Some of that's being absorbed, but most of it's bouncing back into space. And at this stage, if this continues as it is, the planet's going to be pretty cold. Space is really, really cold. So if this was the situation, our planet would be really, really cold and unlivable. So clearly something else is happening here. That's where our volcanoes come in. So when our volcanoes erupt, as we've said, they give out these greenhouse gases, carbon dioxide, sulfur dioxide. And what that does is that creates this layer that we talked about, that layer of greenhouse gases. And that's really useful for us initially because what it does is it traps the heat in and it keeps us warm enough. So by having this layer, it means that we're able to keep a constant temperature on our planet, which is good for life. Problem is, however, as these volcanoes continue to erupt, this layer of greenhouse gases gets warmer and warmer and warmer. Add into that swamps, which have lots of rotting material, which give out another greenhouse gas, something called methane, and you start to build up a really strong layer. So if this was the only process going on, what you would have is an increasingly hotter and hotter planet, which wouldn't be able to be lived on. So something else must be happening. That's where our forests come in. So our forests are brilliant because they regulate the Earth's temperature. So what they do is they take in the carbon dioxide, so they make that layer around the planet thinner, and they give out oxygen. Now oxygen isn't a greenhouse gas, but it is a really important gas for us and for living things. So this situation with the volcanoes and the swamps giving off greenhouse gases and the forests and jungles taking in carbon dioxide and taking in greenhouse gases creates an equilibrium. And this is a situation that our planet found itself in for millions and millions of years until something changed. And that change, of course, was human beings. Human beings have had a massive impact on that equilibrium. We've changed things hugely since our arrival on the planet. We're going to look into those things in the next video and talk about how humans have had an impact on climate change. I wanted to leave you with this. Some people use these natural causes of climate change to argue that humans haven't had an impact on the world's climate. Now, we already might have a different idea of that, but I want to leave you with that thought and what you think to that statement. Okay, so that was a real quick whistle-stop tour and revision of climate change, the natural causes of climate change. I hope you learned something. I hope you found it useful. If you've got any questions or there's a few things you're not sure about, go back, review the video again. If you're still struggling, feel free to send me an email and I'll do my best to answer it. Thank you very much. I'll see you in the next video. Bye.